Hello everyone, how are you? I hope you are doing great as usual. I'm back with yet another exciting video. I guarantee it. If you keep following my videos, you'll be taking one step towards becoming a badass developer. Today's topic is fascinating. Today we are going to see how to identify the hotspot which takes the most amount of time in our code. This will help you to write clean, fast code. I'm very excited about the video, so let's start. Sometimes a hotspot in an unexpected location may hint at a bug in the program as well. So let's try to understand what is the difference between profiling and timeit. Timeit is the subtraction of timestamp before the start of the code and the end of the code. So basically the difference. But on the other hand, profiling will show which code statements within the method takes the longest time. Okay guys, let's look at this example. To save some time, I've already prepared this example for you. So in this example, so basically I've prepared two different examples to show you two different ways of doing the same thing. One using the C profile and the other one using the third-party library called Pyinstrument. So let's look at the example by using C profile. So in this example, as you can see, I have imported C profile, which is a built-in package, IO, pstats, random, system, and the wraps. So basically, I've prepared a profile decorator for this example, which takes as a function. You guys know already what is a decorator. So as you can see here in this, what I'm doing is basically I'm creating object of C profile, then I'm enabling it, then I'm calling the function here, taking the result of it, disabling it, then creating a stream of it. So basically I'm sorting it according to the time taken by the number of by the line itself. So and at the end I'm simply printing it and then returning it. So basically this is the decorator that I've written. So I've prepared this example. I have created this method which basically runs for 400,000 times. So in this, what I'm doing is I'm taking n1, which is number one, taking mean of it, I'm generating two random numbers from -10 to 10. So it's a very simple program. You will be able to see it. And n2, the logic is same. And at the end, I'm taking a sum of it. And I've written a main function that I've called here. So nothing different here. So now I'll run this program. Okay, yes. So this is the interesting part. If you see here, it is already sorted as I showed you in the decorator itself, that we are sorting the stats. So as you can see here, the total time taken by our code is 1.7 seconds, and the most amount of time taken by our code line is of random py, which is this random package, and then the second one is 0.366 second. It is of also random, and the third one is this method which only took 0.245 seconds. So it was fairly easy. And the other one is random int function of this. So like this you can profile your method and see the execution time line by line, and then you can identify where it is taking much time and how you can optimize it. Guys, another interesting to look at here is we have used min or max. You might have wondered like which takes more time. So as you can see here, it is taking 0.035 and 0.035, which is exactly the same for both of them, which is built-in method max and min. So this shows that how efficiently the overall Python code is written. That's nice. So this was the first example. Okay. I know and I agree that this this way of looking at the timing is not that efficient. So I'm going to show you a better way of analyzing or profiling your code, which is using this PyInstrument, which is a third party library. You can install this third party library by using this command pip install PyInstrument, and you will find a lot of documentation for PyInstrument online as well, but those are old ones, so I'll prefer you to stick to this implementation that I've written, which is fairly new, and it is not present in their documentation. I've taken it from their change log itself. So guys, once you have installed this, the program is very simple. The program I used earlier, I've taken the same program. I'm importing the random and importing this PyInstrument. You need to import this profiler, and in this main method, what I'm doing is I'm creating an object of this profiler class, and I'm simply writing prof.start. So basically this will tell the our module that we want to profile our code after this. So basically this for loop we want to profile. So the code is same, and I'm simply stopping it and then printing it. So let's directly see the output of it. Okay, now it's working. Okay, it's done. So now you can see guys, it's so easy to see and it is easily very readable. Just by looking at it you can tell that it is working fine. And yes, there can be a difference of a few milliseconds. You don't have to worry because this profiler adds a couple of seconds, so couple of microseconds I should say. So yes, so the overall execution time took 1.926, and the randint basically this took the most amount of time out of this whole program, which is of 1.590. And in that also a random range function between this took this much time, and then our method, then max and min. So it's all simple. This is how you can profile your long big methods and analyze them and optimize them in a much better way. So I hope you liked it. With this we have come towards the end of our video. Thank you so much guys for watching it. I hope you liked my work. Please consider subscribing to the channel as more such content is on the way.